Okay, welcome all. Today we are going to continue the topic that is instruction set of 8051, which is the third chapter in the microcontroller programming subject of electronics and instrumentation branch C18 curriculum, Telangana Diploma College. Till now we have discussed the 8 instructions of data transfer group with explanation and a good example. Now we are going to continue the topic, and we can learn what are the remaining data transfer group instructions. In that, the first one, that means the ninth one, continuation with the yesterday's class. The ninth instruction is move direct comma rn. Move space direct comma rn, where we know rn is the register, that is common register r0 to r7. We represent it as a rn, and the direct is the address. Direct is the address given. So here the source is the register in which we have the required data, and the destination is a address mentioned in this instruction, which is a memory address of the 8051 microcontroller. So what will happen when this instruction is executed by the microcontroller? That is, the contents of rn registers are copied onto the direct address. That is the where the address is mentioned, and the data remains in the rn register mentioned in the instructions. That is, it just copies, it does not cut. The data will remain in both places. That is the main function of this data transfer group of instructions, which we have already discussed in the previous video lesson. Example, if you take, that is move space 55h, that is the address, and r7 is the register. Then you can draw a table like this in the slide. If you see the above, we have a table, right? Move 55h comma r7, you can write, and before execution the 55h has some random data xx, and r7 register will have a data of something, say 15h or 05h. Then you can draw the same table, that is after execution the 55h will have the same contents of this r7 register, which I have mentioned in this, that is 15h 15 or 05h. The same r7 will also have 15h remain there. Now moving on to the next instruction, move mov direct comma hash data. And we have already discussed addressing modes in the second chapter video lessons. In that, we have discussed different types of addressing modes with names: immediate addressing mode, direct addressing mode, register addressing mode, indirect addressing mode, like that. So one should able to tell after we write the instruction in the program. That is, we see that is an example, move direct comma hash data. So what is the addressing mode here? Simply it is a immediate addressing mode we have used, because the data which we are supplied in this instruction is a directly mentioned in the instruction, and it is distinguished by a sign, that is hash pound sign. Now see the description. An immediate data is moved into internal RAM memory location whose address is specified directly in the instruction. Note, the destination can be SFR also. That means the destination which is we have mentioned direct here, it is will also be a special function register, and the special function register's address already we have learned about this address, and we have seen those addresses in the first chapter itself. That is, if you can remember, the A register, B register, and remaining registers also have some special addresses allocated to them in the memory. And what we'll do, that is the operation. The data directly we have mentioned in the instruction will be directly copied into the contents of the address mentioned in this instruction, and the parenthesis around this direct will represent, that is, the contents of this direct address are copied from the data we mentioned in the instruction. So example, if I say move a 38h comma hash 90h, hash means it is the data, so 90h is the required data which is will be copied into the RAM location having the address 38h. And moving on to the next instruction, mov space direct comma direct. So this is a direct addressing mode in which the source and destination both are direct addresses given. So the contents of source address will be copied onto the destination address location. So that is the description mentioned here. Description: the content of one internal RAM or SFR is moved to another internal RAM or SFR. The address of the source and destination are directly specified in the instruction. So I have called it direct as a memory location. So the memory location is in the internal memory itself, that is the internal RAM or SFR. So the operation, in the operation, I think there is a mistake we have written here, because both sides it will be direct address. So in the parenthesis both should be direct. Please correct yourself. That is, in the both sides to the arrow we should write direct, and in the parenthesis has to be mentioned. So the contents of source direct address will be copied onto the contents of destination address. The example is move 088h comma 78h. See why we are writing 0, because in the first chapter we have seen that the addresses has to be started with a number. 0 is a number and A is an alphabet. So instead of writing directly A, we can write 0A. There is nothing wrong in it. And the B register, which we commonly use it in the programs, the memory address or address location of B register is F0. So as F is a alphabet, so we should write instead of B as 0F0. So in this example, move 088h comma 78h, both are the direct addresses mentioning. So the move the contents of RAM location 78h into A8h, which is interrupt enable register. So A8 is a I register. That is, we can remember, or we can see the table in the first chapter. That is, in the example move A8h comma 78h. Before execution, we have in the A8, that is the destination, have some random data XXH address of I, and the 78h has, let us say it is 88. The contents are 88, and after execution the A8h became 88 and the 78 became 88. 78 already it is 88. That means the contents of the source will not be get changed, only the destination will be changed. And now moving on to the 12th instruction in this data transfer group. Move mov direct comma at the rate ri. I request every student who are watching this video to please write down all those instructions, at least the syntax and the main instruction itself, that is mov space direct comma at the rate array. No need to write this description, operation or example. If you want to write the operation, and let us say an example. Don't write the table also. Table you can even write in the exam directly, but please write down the instruction, operation and example. That is, whenever you want to revise, it will be very easy and you will be habituated to write those instructions. So I hope everyone is writing. The 12th instruction is move direct comma at the rate or I. Description at the rate, if you remember from the addressing modes, right, which type of addressing mode is, please guess it. We have used at the rate symbol. Description, the content of internal RAM whose address is specified by RI, it's not RN. You can remember RN means R0 to R7. We can use any of those 8 registers, but RI means we can use only 2 registers, that is R0 or R1. So in the description part, the content of internal RAM whose address is specified by RI is moved to another internal RAM or SFR whose address is directly specified in the instruction. The register RI can be either R0 or R1. So this is indirect addressing. Indirect, that means if you see the operation to the left side, that is the destination, we can write a single parenthesis and in between the parenthesis we have direct. That is the address whichever mentioned in the instruction as the destination, the contents of this destination are copied from where we have mentioned the register in the source, but the register will point to, the register will have some data or contents. The content is not what we require. This content will point out to some of the data or content where the memory location of that content is represented by the register's contents. Okay, it may be a little bit confusing, but you have already seen the immediate addressing mode and explanation also, and the indirect addressing mode, so you can easily understand, right? So that's why we have used 2 parentheses. It's not a typing mistake. We should use 2 parentheses, 2 pairs to write this type of indirect addressing mode. That is the internal RAM address mentioned by this array will be the address of the required content, and this content will be copied onto the address mentioned in this instruction at the destination point. You see the example, move 74h comma at the rate R1. So before execution, 74h, that is the destination, have some random data, that is XXH, and the R1 is the internal RAM. It has the contents, this register has contents 47h, and the 47h is pointing to, 47 address is pointing to some data, that is 85h. So in this sequence, the original content we required is the data 85h, so that will be copied onto the 74h, that is the destination address. So after execution, 74h as 85h, and the R1 is does not alter, it has the same address, that is 47h, and the 47h has again 85h, that also not disturbed. So like this, the indirect addressing mode will be mentioned in this data transfer group of instructions. Now moving on to the next instruction, 13th instruction in this data transfer group, move @ri comma a. Move @ri comma a. So it is just the reverse of this operation we have seen. The source here is accumulator and the destination is a indirect address, indirect register. The content of accumulator is moved to an internal RAM location whose address is specified by RI register. The register RI can be either R0 or R1. So that in the operation part, the left side, that is the destination part, has two parentheses. You see, two parentheses, and to the right side we have the accumulator register. So we need content, right? So for the content we should write single parenthesis. The example is move @r0 comma a, and the same values you can take, or you can take different values also. Move @r0 comma a. Let us say r0 has some data, same this 47h, and the 47h has some random data, and the accumulator has some 85h as the content, that is the before execution. Then after execution, the 47h which is pointed by r0 will have that 85h data. From the accumulator it is copied, and the accumulator will be remain as 85h, and the r0 will have same 47h. So like that you can write in the exam with a good example. I hope everyone has understood that. If not, please write it down now itself. The move @r0 comma a, example of move @r0 comma a. Please take these same values in this table, move @r0 comma a. Please write it down by yourself before execution and after execution. I don't want you to write it because of to pass this time, to time pass, but I want you to write it because you will excel in this. That means you will understand well, you will know how to write an example. If you can't remember the examples from this textbook or from what I have already displayed in these slides, but you can write it by yourself in the examination itself, on the spot itself. So writing some examples will help you. So please try it now. I'll give you 2 minutes. I hope everyone has completed this example. Now moving on to the 14th instruction in this group, that is move at the rate ri comma hash data. Move at the rate ri comma hash data. You may have some doubt, that is which type of addressing mode is this, right? So it is immediate addressing mode, because the data, required data, is mentioned with immediate addressing mode type. It is not the destination we want, it is the source. It is the source we need, from where we have to take the data. That is important. And the 13th one, you may have dot move at the rate ri comma a. That is the register addressing mode, because the data source is mentioned as a accumulator register. So this is a register addressing mode, 13th one. And the 14th one is a immediate addressing mode. The description: the immediate data given in the instruction is moved to an internal RAM location whose address is specified by RI register. The register RI can be R0 or R1. So the operation is double parenthesis to the destination side, and the data simply directly we can write data to the source side. The example is move at the rate R0 comma 44H. And the 15th instruction is move at the rate RI comma direct. This is the 15th instruction in this data group. And if you want to write this example and before execution, after execution, you can try. Yes, you must try it now. Please draw the table for this example. Move at the rate R0 comma 44H. It's not 44H actually, right? There is a mistake. If anyone has identified the mistake, then it's very well and good, because we have mentioned the data in the 14th instruction, so it must be preceded by the sign hash. So it must be move at the rate R0 comma hash 44H. Hash 44H. Please write it as hash 44H and draw the table for the example, that is before execution and after execution. Please write it down. I hope everyone has completed that small assignment also. Now, the 15th instruction in this data transfer group, that is move at the rate RI comma direct. Move at the rate RI comma direct instruction. So from the description, the contents of internal RAM receptor whose address is directly specified in the instruction is moved another internal RAM. So source is a direct address and the destination is an indirect address mentioned by this RI register. So whose address is specified by RI register, the register RI can be either R0 or R1. So the operation double parenthesis to the destination and single parenthesis to the source. And example move at the rate R0 comma 30H. So before execution, the R0 has 50H content, which is a address of the required destination, that it has some random value XXH, and 3D, it is not 30, it is 3DH. The source is a 3DH address which has some data for C4C. So the requirement is 4CH. So the 4CH will be copied onto the address 55H. and R0 will have same 55H. And the next instruction is, now we are going to the 16-bit data. Till now we have seen about the only 8-bit data. Now we are dealing with the 16-bit data. So move DPTR, data pointer. If you can remember, DPTR is a data pointer register which is a 16-bit byte, which is used to represent the 16-bit data from the external source. Description: move 16-bit immediate data into data pointer register, which is a 16-bit register. So the 16-bit data will be directly copied into this DPTR register. This is the instruction which deals with 16-bit data transfer operation. DPTR register is copied with this 16-bit data. Move DPTR comma hash 8000 8000, as it is a hexadecimal number, from conversion of hexadecimal to binary. We require each and every digit of this hexadecimal will be converted into equivalent 4-bit binary number, and you can write the example for that. Now the 17th instruction, move x a comma at the rate ri. Move x. So till now we have written move, but now we are writing move x. X means external RAM. We are accessing the data from the external RAM. Description: move the contents of external RAM memory location whose address is specified by register Ri into accumulator. Here the external RAM may not be compulsorily have 16-bit data. We can take the 8-bit also. So the Ri internal register R0 or R1 is a 8-bit. So the external memory, the 8 bits of the required external memory will be directly copied to this accumulator register, the specified by the RI register, which will have the data. Note: while accessing external RAM, RI can address 256 bytes and DPTR can address 64 kilobytes. MoveX instruction is used to access external RAM or IO address. There are two sets of RAM address between 00H2, 00H and FFH. One for internal 8051 RAM and another for RAM external to 8051. And the operation is, the contents of accumulator are copied from the external indirect register address. So example is movex a comma at the rate R1. We can take the example and write. You can do it at your home as an homework or assignment. Next is movex a comma at the rate DPTR. The description: move the contents of the external RAM memory location whose address is specified by data pointer into accumulator. In external moves, the data transfer is only between memory and accumulator. So operation, the contents of accumulator are transferred from the DPTR indirect address mentioned by this DPTR register. See in the note point, in external, I think some point is missing there. In external memory moves, the data transfer is only between memory and accumulator. The example, if you study the example, we can understand it better well. Movex a comma at the rate DPTR. Before execution, A has some random data, DPTR has some 16-bit data, and 16-bit address is mentioned, and this 16-bit address will be pointed to the 8-bit data, and that 8-bit will be transferred to the accumulator. So making the accumulator has the contents of 0F, and the DPTR has 16-bit address, and the 16-bit address is pointed out to some 8-bit data. And the same can be explained from this 19th instruction, movex at the rate DPTR comma A. Move the contents of accumulator into external RAM location whose address is specified by the data pointer. And the operation at the rate means 2 parentheses and single means 1 parenthesis. Movex at the rate DPTR comma A. 20th instruction move C A comma thread A plus dptr. A little bit complex here. So move the contents of external RAM memory location whose address is formed by adding the accumulator contents with the contents of dptr. It is relative addressing. Adding the relative addressing mode topic, and the contents of accumulator will be added to the contents of dptr, and the final address will point out some data, some content that will be copied onto this accumulator register. This instruction is called as move code byte. Move code. The C in move C indicates that it's a code byte. So the accumulator will be copied from the register of internal indirect addressing, which is obtained by this adding the contents of accumulator and dptr. Examples: this instruction copies the code byte found at the external RAM address formed by adding A and dptr at an address 12,000H plus 61H. These are the examples, 1261H to 8. The example, if you see, before execution accumulator has some content 61H and dptr has 8000H, and the 8061 is pointed to 79H. And after execution the 79H will be copied onto the accumulator, and the dptr and 8061 will have same values. Move A comma at the rate A plus PC. Here the dptr is replaced with PC, program counter. So if you remember the PC, the program counter will point out to the immediate or the next instruction which is going to be executed. So description: move the contents of the external ROM memory location. So address is formed by adding the accumulator content with the contents of program counter. Destination is always an accumulator. So PC will be incremented first, and that PC will be added. Why it is incremented? Because it has to point out to the next instruction. Before executing this instruction, the PC point outs to this instruction itself, the address of this instruction. But while we are executing this instruction, for example move A comma at the rate A plus PC, if we are executing this instruction, the PC will point out to the next instruction. So obviously PC will be incremented, and the contents of A will be copied from the addition of A plus PC, and the relative address will be copied, and relative contents will be copied into this accumulator. So let the contents of PC are 4000, contents of A are 550H, and move C A comma at the rate A plus PC. So this instruction copies the code byte. Yes, it must be move C. Sorry for the mistake. It should be move C A comma at the rate A plus PC. And before execution, A have 50H, and PC will be 4000H and 4051, because PC will be incremented by 1. 4001 plus A, that is 50, so it will become 4051, which will point out to some data, that is 39H. Examples. These are all the examples. No need to remember these values. And as it is a external, the PC is a 16-bit pointer. Okay, so the 13H, which is the required data, will be copied onto the accumulator, and PC will be remains, and 4000H will also has the same data before and after execution. So these are somewhat little bit complex because external memory is involved. Move C A comma at the rate A plus PC, and the accumulator must be the destination always in this type of instruction. Still we need to go some 6 or 7 instructions, and we have completed general data transfer, and now we are going to stock operations of this push and pop instructions, stock pointer operations. And in the stock pointer, the push operation means loading the data onto the stock pointer, and the pop operation means removing the data or removing the data from the stack pointer. The push direct is the instruction. push space direct. That is, the contents of this direct address will be pushed onto the stock pointer, pushed onto the stock. Now the stock pointer will point out to the address of the top of stack. Description: the stock pointer is incremented by 1. So during the execution of this instruction, the stock pointer will be incremented by 1 because it is adding the data onto the stock pointer. So the stock pointer will point out to the top of stack, so that will be incremented by 1. Push the contents of internal RAM memory location or SFR on the stack addressed by stock pointer. The stack is the internal RAM area only, and push and pop instructions are used to move the data between internal RAM stack and internal RAM. Operation is stock pointer will be incremented by 1, that is stock pointer plus 1 in the operation, and the stock pointer will be address will be copied by the contents of this direct address. Example is push 0f 0h. The instruction increments the stock pointer by 1 and store the contents of register B, because 0f0, if you remember, that is the address of the B register, to the internal RAM location addressed by the stock pointer. Example, before execution, let us assume stock pointer is representing 07h, and 0f0 is the B register has 82h, and the 07h has some random data. Then after execution, the stock pointer will be incremented, that is 08h, and the 0f0, that is the B register, has the same value 82h, and that 82h will be copied onto the 07, that is the previously pointed stock pointer value, because 0h is empty. Before execution, stock pointer is pointed to the top of the stock, and after execution it will be incremented to the 08. So 07h will be occupied with this 82h content. The pop direct. Next instruction is pop direct. This instruction moves the contents of stack addressed by stock pointer to the internal RAM, whose address is given within the instruction. Stock pointer is decremented by 1 because we are removing the data, we are taking out the data from the stack. So when stack reaches to FFH, it takes over to 00h, RAM ends at 7f. So pushing the stock contents above 7f will result in error, right? Because the RAM ends at 7f. Internal RAM is 128 bytes, right? 7f means 127. So 0 to 127 we have 128 bytes, 128 memory locations. And stock reaches to FFH, that is the top of the RAM. Then afterwards, if we still push, then it will be rolls over to 00h. Then the data will be stored from the start. The stack should be normally initiated above the register banks, because the lower register banks, 32 register banks, that is 4 banks will be fixed. And after that we have the bit addressable areas, right? So those has to be taken into account. Only address and not register names are used in this instruction. So only the address, direct address, that instruction itself, push direct and pop direct, not the push A, push B, that means push R not R7. So like that we didn't have this type of instruction, and that will result in illegal instruction. So we need to write push address and pop address. And the operation of this pop instruction, that is stock pointer directly, the stock pointer contents will be copied into the address, and after that the stock pointer will be decremented by 1 because the data is taken out. So it should be pointed to the last data, that is the top of the stack, right? So that is after execution, the stock pointer will be decremented by 1. So pop 0e0h, that is an address. This instruction copies the contents of the internal RAM memory location addressed by the stock pointer to the accumulator. Then the stack pointer is decremented by 1. This instruction copies the contents of the internal RAM location addressed by the stack pointer to the accumulator. That is 0e0 is for accumulator and 0f0 is for B register. So that's why we didn't write as pop A. Pop A means it is a register type of addressing, so it is not supported by this pop instruction. So we need to write pop direct. that is the address of the accumulator register, which is 0E0H. The stock pointer is decremented by 1. So with an example pop 0E0H, before execution accumulator will have some random data and stock pointer is, let us assume 08H, and 08H will have some content 67H. Then after execution stock pointer will be decremented, that is 08H will become 07H, and 08H which is already presented in the stock, that is 16H, which is copied onto this accumulator. There is a mistake here. After execution 0E0H should have the contents, that is 67H. It's not double X, it should be 67H. Okay, and we can move on with the next instruction, but it is already 41 minutes. We have barely left with only 3 to 4 minutes of today's class. So a quickly revision of these all instructions is suffice for today's lesson. So we have almost 26 to 27 data transfer type of instructions, in which some are classified with we can remember like this: move instructions, move X and move C. We have seen all these 3 types of move instructions: move external, and move copy the code. And stack pointer also we have seen, that is push instruction, push direct and pop direct. And we have to learn about this exchange type of instruction, which are only 2. We can quickly complete in tomorrow's lesson, and we can move on to the next type of instructions also. So once you write all the list of all these instructions, that is 26 or 27 instructions on a single paper, yes, one must write all those instructions, so we can see which type of instructions are possible while writing the code, which are illegal, that means which will prompt out the instruction errors, that is syntax errors. So some of the instructions will not be allowed, right? Move a comma rn is possible, move a comma hash data, a comma direct, a comma @array. Then afterwards move rn comma a. You can write side by side, move a comma all these instructions. Then afterwards the fifth one to the side, move rn comma a, rn comma hash data, rn comma direct comma a, move direct comma rn, move direct comma hash data, direct comma direct. And did we find move hash data comma hash data? So think about like that is it possible or not? Move hash data comma hash data, did we encounter such type of instruction or not? If not, why? Move direct comma @array, move @array comma a, and is it possible that move @array comma move @array, like that, move array comma array? So such type of things will come into your mind while writing the code, that is writing the program. Now you will not question that whether that type of instruction will execute or not. But if you have that doubts in your mind, today itself or by reading this topic only, then you will have clear cut idea about writing the program, that this is illegal, we cannot write such type of instructions, that is 8051 does not allow it. So such type of analytical thing should be required in this subject. Okay, not only reading the subject and learning what it has, and we need to understand what it does not support also. What it does not support, that 8051 does not support this instruction, that instruction, the property is not there. So we need to have an idea, then only we can limit ourselves from committing the mistakes by writing the program. So with this we can conclude today's lesson. We can meet tomorrow and go on to learn the next topics. I request everyone to please practice the writing some codes before coming to tomorrow's lesson, video lesson. Some basic programs, right? Transferring the data from one instruction to another instruction. And you write with the examples of, and you see before execution what it happens and after execution what it happens. Then we can actually in the laboratory we can see whether it is getting transferred in real or not. We are assuming it in the paper itself, that means it is transferring, but we have to see it in real. whether it is transferred or not, and we have to check whether the register received that data or not. So these all has to be done in the practical sessions, which will be available in this your laboratory, or we can use the software also. Please go and Google search for the 8051 microcontroller software and try it yourself. Then only you can learn from the basics also. It is more do it yourself type of subject than the laboratory. So people, please try that one, and I'm closing today's session. Thank you one and all.